Thanks that I can be part of this nice conference. My name is Fischer, and I am a PhD student at the TUM School of Engineering. And I am working at the chair of materials handling, material flow, logistics. This is the chair from Professor Fottner. And yeah, the title of the paper I will present is Integrating BIM for DES-based resource scheduling, a validation for pilot drilling production. And as the title reveals, it is about the combination of discrete event simulation and information and building information modeling, like BIM. So I therefore summarize the motivation of writing this paper. We developed the current state of technology in praxis, and I will then present the methodology of integrating BIM into the DES model, the implementation, the results, and the validation of the case study. And at the end, I will present you the conclusion and the outlook. So first of all, today's construction projects show a very high complexity. And on the one hand, we can see an increased use of Industry 4.0 technologies. On the other hand, we can see that these improvements are not used. So DES, a discrete event simulation, as one proven tool for evaluating the construction performances and for providing valuable feedback and decision support, will be part of, can be used for as a tool for showing the productivity in construction industry, because it can predict the construction processes and schedule optimization. However, this is not yet adopted in the construction industry. So they recommend that in literature that for future DES models, you should once in one point make a simplification, and on another point you should integrate new technology to make the simulation more flexible, and then brings us to show the efforts of the simulation, so that the construction site can use it. In the last decade, researchers tried to address this abuse by integrating BIM into the simulation. Why? BIM provides the product and process information, and especially in Germany, there is a high effort to integrate BIM into the guidelines for building construction sites. So BIM can be used as a database for the digital twin, which we want to achieve with the simulation. And as shown in this graphic, in the future there will exist hopefully a BIM model for every project. Means that we have an interoperable standard format IFC with the cost, resources, but also geometry, and which we can put into the simulation as a database. And with this feed, we can update even though the BIM model, but also given a decision-making support for the planning, for the planners. So our research methodology is based on the object-oriented modeling for generating the 4D or 5D BIM models according to Bormann. We can see here the scheme. So in the first phase, we just analyze the problem. In the second phase, we find the solution, and develop conceptual model, and in the last phase we develop the model by using software. Then we check it and validate it, and then we convert it to a proper format. In this case, this XML file. And in our work, we use the XBIM toolkit for the model development, the constructivity software for as a model checker, and the tool IFC convert as a BIM converter. But in the first case, we needed to analyze the common BIM format for pile drilling. Why for pile drilling production? This is the main objective is in our research project. So we have here heavy equipment intensive application, and this is a widely used pile production method. They use this rotary drilling rig to make large diameter board piles, and this use case is very nice for the simulation to optimize the process flow and also to optimize the scheduling. So which pile after the other you have to build. So this was the focus in this paper, and as we looked at the BIM models, we had to see that the information about the processes are missing right now. So the current state, we here compared 3 sources. We compared 2 real projects where we could find or we could get a BIM model of the pile production project, and C is a minimum standard, a German one for pile for the special civil engineering industry. Yeah, and we compared them under different categories, and our conclusion was that these BIM models provide mainly geometry data, but not that much about the process itself. So, oops, I'm sorry. In the first case, we did our own BIM model. As you can see here, of course, the geometry was interesting, but also some data about the date when they have to produce, because the tech time for pile production is defined as the duration per pile length, and we also needed this initial schedule for comparing different scenarios on resource scheduling. So this was the BIM model which we created, and this BIM model we want to integrate it, or we integrated into a simulation, and therefore we needed or we developed the simulation layout with the Siemens DES software, and we imported generated XML files, and we also developed a 2-level model. So the first model is to visualize the pile production itself, and the second is the state machine, the state of the machine or the equipment, so in which phase the equipment is. Then the second level is here shown. There we concentrate on the concrete delivery. So the 2 levels consists on 2 different processes on the construction side. And this is also shown in the simulation logic. This is here just a value stream map, but it shows the production itself, which we set up. So we have first the drilling, then the drilling of the hole. This drilling will be accepted if it's on the right length, and then there is a reinforcing cage to to stabilize the pile in the end. And we have the concreting, and this concreting part here was part of the of our case study, which we see next. So just to give you an impression, I hope you can see this. We have here the initialization of the input data via BIM, and then here in this part we can see the production of the pile, the visualization of the pile, and in this, with these elements, we can see in which state the equipment is. Yeah, and in the end, if the pile is finished, we have here the duration. Oh, I'm sorry. So here is also a small demo about the level 2 stage, so about the concrete delivery. We have here the visualization of the concrete batch plan, and in this corner here the concreting, and we will see how the concrete mixer is getting loaded here in this concrete batch plan, and then moves forward to the construction site, and here the concreting is starting, and simultaneously we have here the scheduling to control the material flow here. I will just go further because I think the time is.
Yeah, so Anna, maybe you want to wrap up.
Yeah, okay. So this is just the conclusion. We had a validation of we varied two concrete mixers, and we got a reducing time of 14%. And so we come to the conclusion and the outlook. We had analyzed the requirements for a BIM model, then we implement an own BIM model, and also we implemented a modular simulation model with 2 levels, and we had 2 conclusions. One, we had to implement the process information into the BIM model for the DES model, and conclusion 2 is that of course the BIM model is very suitable for the DES model. And for an outlook, we have 3 or 4 points. The digital twin requires the export of data from DES to BIM. So we needed bi-directional data integration. We can further add another Industry 4.0 technology, and of course the case study was very simple, and we can make it more complex.